Today's topic is cost optimization in cloud systems design. Cost optimization is an essential part of cloud financial management that cloud architects must master in systems design. Subscribe to the channel and like this video. The industry calls this discipline FinOps, short for Cloud Financial Operations. A big part of it is monitoring what you run and right-sizing it. You spend the least that still meets your performance promises. Right-sizing means matching each resource to the demand it actually receives. That is rarely the demand you guessed at during launch week. Monitoring here means utilization data, not just invoices. A bill tells you what you spent. Utilization tells you what you wasted. Cutting spend until users notice is not optimization. It is a self-inflicted outage. Cost is a design constraint you either handle early or pay for repeatedly. In a simple system, the work is tactical. You turn off what nobody uses. At scale, it becomes strategic because architecture locks in a spending shape for years. A pattern costing a fraction of a cent per request looks free in testing. At 1 billion requests, it is a six-figure line item. Cloud pricing also inverts an old habit. Capacity you never use still bills you hourly. Understanding this lets you argue for an architecture in the language the business funds. Right-sizing starts with measurement, because you cannot shrink what you have not observed. Pull at least 2 weeks of CPU, memory, and disk metrics. That captures a full traffic cycle. The common finding is a fleet averaging 5 to 15% CPU. AWS Compute Optimizer, Azure Advisor, and Google Cloud Recommender all read those metrics. Each one suggests a smaller shape for you. Move down one size at a time. Watch the peak, not the average. Switching processor architecture is often the cheapest win. On AWS, Graviton instances often deliver better price performance for general workloads. Right-sizing is never finished. Last quarter's correct size is this quarter's waste. The same virtual machine has several prices, and choosing between them requires no code change. On demand is the flexible default. It is also the most expensive way to run anything predictable. Commitment pricing trades flexibility for a discount. That is savings plans and reserved instances on AWS, reservations on Azure, and committed use discounts on Google Cloud. You promise 1 or 3 years of usage. In return, you pay 30 to 70% below on demand. What about the cheapest option of all? Spot instances on AWS, Spot VMs on Azure and Google Cloud, and the older preemptible VMs all sell spare capacity at 70 to 90% off. The provider can reclaim that capacity with about 2 minutes of warning, so Spot suits batch processing, rendering, and continuous integration runners. A healthy fleet blends all three. Commit the steady baseline and push interruptible work onto Spot. Elasticity is where cloud economics differ most from a data center you own. Auto-scaling lets capacity follow demand. You stop paying peak rates during off-peak hours. A fleet sized for a lunchtime spike sits mostly empty overnight. Shutting non-production environments outside working hours removes roughly 2/3 of their weekly runtime. Serverless takes the idea further. AWS Lambda and Google Cloud Run bill only while your code executes. For spiky, low-duty cycle workloads, that beats an always-on instance waiting for traffic. The trade-off reverses at sustained volume. A busy container often costs less per request. Architectural efficiency comes down to duty cycle. Ask what fraction of each hour your workload is genuinely working. Much cloud waste is not oversized, it is simply forgotten. Unattached storage volumes, idle load balancers, unused IP addresses, and old snapshots bill quietly and forever. Run a scheduled sweep for resources with no attachment and no traffic. Treat a missing owner tag as a deletion candidate. Storage rewards a different technique. Access patterns decay with age, while the data stays valuable. Lifecycle policies move objects down the tiers automatically. Amazon S3 shifts data from standard to infrequent access to Glacier Deep Archive on a schedule. Archival tiers cost roughly a 20th of standard object storage per gigabyte. Match the tier to the retrieval expectation. Deep Archive charges a real fee and can take hours to restore. Data transfer surprises teams most often because nothing on the architecture diagram looks expensive. Traffic leaving a provider for the internet is called egress. It typically costs around 9 cents per gigabyte in United States regions. Traffic between availability zones is billed too. A chatty service spread across zones pays a tax on every internal call. NAT gateways charge an hourly rate plus a per gigabyte processing fee. Why put a content delivery network in front? A network like Amazon CloudFront cuts egress costs and improves latency at the same time. VPC endpoints keep traffic to services like Amazon S3 inside the provider network. Trace the data path in every design review. Ask which arrows cross a zone, a region, or the internet. You cannot optimize spending you cannot attribute, so visibility comes before any cut. Cost allocation tags attach an owner, an environment, and a cost center to every resource. Reliable tags let you produce showback, which shows each team what it consumed. Chargeback goes further and actually bills them for it. Showback alone changes behavior well. Most overspending is invisible rather than deliberate. Budgets with threshold alerts catch slow drift. They warn you at 80% of plan instead of on the invoice. What catches the fast version? Anomaly detection flags a sudden spike within about a day. That is how a runaway test loop or a leaked credential gets caught early. Total spending is a weak signal because a bill growing slower than revenue is good news. Unit economics divides cost by a business quantity instead. That gives you cost per transaction, per customer, or per 1,000 requests. The ratio tells you whether an architecture is getting more efficient or whether it is just serving more traffic. It also aligns spending with business value. You can show cost per order fell 40% while total spending rose. Total cost of ownership widens the frame further. It counts engineering hours and operational burden alongside the hourly price. A managed database costing more per hour but removing a week of patching is usually cheaper. The cultural half of this is cost ownership. Engineers who never see the price of their choices cannot optimize them. Put spending data in front of the teams creating it. One expense intentionally is continuous because every price change reopens a decision you already made. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist. The obvious return is budget freed for work that actually differentiates your product. Efficiency and performance move together. The workload optimization that finds a wasteful query finds a slow one. Deleting forgotten resources shrinks your attack surface. An unowned server nobody monitors is what an attacker hopes to find. It also buys trust. A team that predicts its own spending gets approval for the next platform. Cost optimization is a real trade-off, and there are places it should lose. Never trade away reliability targets you have committed to. Never trade away reliability targets usually cost more than a year of the redundancy you removed. Aggressive right-sizing without headroom is a common failure. An instance running at 90% has no room for a surge. Long commitments are wrong for genuinely uncertain workloads. Stay on demand until your baseline is measured. Spot capacity is the wrong answer for anything a user is waiting on synchronously. When cost conflicts with security, logging, or backups, spend the money and document why. Cost optimization is monitoring real utilization and right-sizing resources so you spend the minimum that still meets your performance and reliability commitments. It is tactical in a small system where you shut down idle resources and pick the correct size. It is strategic at scale. Pricing models, elasticity, data transfer paths, and unit economics shape the bill for years. Establish visibility first through tagging and alerting, then apply the levers in order of size. Treat it as a continuous practice rather than a cleanup project. Well, that does it for now. Hope you got something out of this video. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io. That's systemsarchitect.io and codeguides.io.